All right, we have 5.6. 5.6 is now going to start talking about our quadratics that we've been factoring and we've been solving, and we've been talking about square roots and complex numbers. But now we need to start putting together some more meaning behind it, the pictures and stuff. So here we have 5.6, a quadratic equation. In its most general form, it is ax squared plus bx plus c equal to 0. And it always has to equal 0. A, b, and c belong to the reals, and this little symbol is just kind of a little backwards e. Means belongs to the reals. They are real numbers, meaning they can be fractions, decimals, square roots, anything. As long as they're real, that can be there, with the exception that a cannot be 0. Because if a cannot be 0, then there would be no x squared if it was 0. So what's important about this quadratic is that the quadratic has a highest exponent of 2. Its graph is called a parabola. And it looks like a U shape, either going upwards or downwards. So we need to know all of these correlations here. The quadratic means a parabola. A parabola is this kind of a shape. If I see this shape, it's a quadratic. The equation has a highest exponent of 2. All of this stuff needs to be interchanged and understood from any type of direction. When we start to solve our quadratics, of which we have done already with our factoring methods when we set each piece equal to 0. We're going to learn some more solving techniques because not everything can be factored. But when we solve our quadratics, what's most important that we understand is we're not just finding x is 2. When we're solving a quadratic, what we are finding, we're finding the roots. We're finding the solutions. We're finding the zeros. These are also known as the x-intercepts. These 4 words are interchanged, and you need to know them backwards, forwards. So on a quiz or test, when it says find the zeros, you know you're finding the same thing as find a root. Find an x-intercept. All these words mean the exact same thing, and they will be used, and you need to know that they're asking for the exact same thing. When we're looking at our equation, we're looking at our picture, and we're trying to find these x-intercepts, we have some different possibilities. Our possibilities is that our parabola could touch in 2 places, and it really makes no difference if I make the picture, if the U shape goes up or if the U shape goes down. What's important here is that we have 2 possible roots. We would call these 2 real roots. They would be 2 real solutions. There would be 2 zeros. There would be 2 x-intercepts. Another option is that my parabola can, again, doesn't matter whether it goes up or down, it can touch my x-axis in one location and then kind of bounce off and go back from where it came from. We would call this one real double root. And it's a double root because it kind of hits and goes up in the same place. So this location happened twice, up and then down. So it's one real. It's real because it touches the x-axis and it's an actual number. It's a double root because it's the same number where it goes up and down at. And then our third option, again, it doesn't matter whether it opens up or opens down, is that our parabola does not touch the x-axis. That means there is no x-intercept. There is no zero. There is no solution. There is no root that are real. And we would say that this is two imaginary roots. So we need to be able to look at a picture and determine how many roots are there that are real or imaginary. But what we're going to do now is we're actually going to find them algebraically. So graphically we can look at it, but then what we need to be able to do for this lesson is be able to find them algebraically. And this is called finding the discriminant. All right, and when you find the discriminant is a number that determines the nature, also type, the type or the nature of the roots of the quadratic. So without solving it, whether it's factoring or a couple other methods that we're going to learn here in a few days, without solving it, we can at least know what kind of picture we're looking at. Does my picture cross my x-axis twice? Does it just touch and go up or down in the same spot? Or does it not touch at all? And that nature is determined by this formula. D equals b squared minus 4ac. Now keep in mind b squared minus 4ac is going to come from that general form. So b is the coefficient of the single, a is the coefficient of the squared, and c is the constant that's by itself. So that's how we get our discriminant. If our discriminant is positive, if it comes out to be a positive number, whatever that number is, if the discriminant is positive, we say that there are two real roots. If we do this b squared minus 4ac of our quadratic equation, and we come out that the discriminant is 0, we say there is one double root. And if we do the discriminant and this time it comes out to be negative, we would say there are two imaginary roots. All right, so all we're doing is we're finding a number. It doesn't tell us what the roots are. It does not tell us where it crosses the x-axis. The only thing it tells us is, does it touch the x-axis 2 times, 1 times, or not at all? So we're going to do 3 examples here. The first example, x squared minus 8x plus 5 is 0. When you're asked to find the discriminant, you are going to follow all these steps. You're going to say a is 1, the leading coefficient. You're going to tell me what is b, in this case negative 8. And you're going to tell me what is c, and in this case it's 5. Then you're going to do the substitution into the formula. You're going to go b squared minus 4ac. And yes, you're going to show me that substitution. Now you can do a little bit of work, you can use your calculator, but you need to then come up with the number, in this case happens to be 44. This is the discriminant, but there's going to be 2 parts to the question. It's going to say find the discriminant, 44, and determine the nature or the type of roots. So because it is positive, you would say positive is 2 real roots. You must show the problem, you must show ABC, the substitution, the discriminant, and then the actual type. The only thing that you could bypass here would be the work in between, because maybe you used your calculator. However, I warn you, if you use your calculator, make sure you use parentheses correctly, because if you don't, you will make a mistake. So let's move on to example number 2. X squared plus 10x plus 25. A is 1, B is 10, C is 25. Yes, write out the ABC. Show me the substitution. So B squared minus 4 times A times C. Show me, you don't have to show the work. It's easy enough to do it. But you then have to come up with what is the discriminant. And the discriminant in this case is 0. Look back up here. If the discriminant is 0, the picture, the type of root that we have is 1 double root. All right, and the last example, 3a squared minus 10a plus 11 is 0. A is 3, B is negative 10, C is 11. When you put together negative 10 squared minus 4 times A times C, we get 100 minus 132 for negative 32, which if the discriminant is negative, we get 2 imaginary roots. Yes, you must show all the steps. Yes, you must use complete words and answers, no shortcuts. And the other thing you need to make sure of is that it always, always, always equals 0. Just like when we are factoring and solving, our equations have to equal 0. If they don't, you need to change them and make it so that it is. So that's going to be 2.6, finding the discriminant.